Alright, this is part 3 of a lesson on polynomials. In this video we're going to be finding the rest of the zeros given a couple zeros from a chart. We'll be discussing whether or not Patricia is right about the two roots for this function, and we will be building a polynomial function from these three zeros that were given. Alright, so let's proceed. Okay, so for number 6, we've got this function. Now, first of all, how many zeros will this function have? Well, okay, there's a little thing called the fundamental theorem of algebra, which says that the number of zeros will be the same as the degree if we count repeated zeros and imaginary zeros. So, this function will have 4 zeros because the degree is 4. So there you go. It's as simple as that. Now use the table below to find all roots of the function g of x. Alright? Technically we should have said zeros. The difference between roots and zeros: functions have zeros, equations have roots. So yeah. So off the table here we see 2 zeros. Okay, we have a 0 there and we have a 0 here, so we've got 2 zeros so far. So we need to find the other 2. Okay, so we will use synthetic division. Alright, let's start our synthetic division. Let's start with the first 0 of 2. Alright, of course the coefficients are 1, -9, 23, -81, and 126. Okay, so I bring down the 1, multiply, I get 2, add, I get -7, multiply, I get -14, add, I get 9, multiply, I get 18, add, I get -63, multiply, I get -126, add, I get 0. Now I can see I could actually do grouping right now, because 9 goes into 63 7 times. If I took a 9 out, you know, if I had the variables in here, it would be like, you know, it'd be x minus 7, and this is, if this would be x minus 7 as well. Whatever. I have another 0 to use, so I'm not going to bother with grouping right now. But I could, just in case anyone's paying attention. Wait, let me stick with this color for one more minute. So because I have another 0, I'm just going to pick up where I left off and do the next 0. So the next 0 is 7. So let's do the 7. Wait. 7. Okay, so if I bring down the 1, I multiply, I get 7. Add, I get 0. Multiply, I get 0. Add, I get 9. Multiply, I get 63. Add, I get 0. Now, this is going to be quadratic. If I put the variables back in, this is going to be x squared plus nothing, and then plus excuse me, plus 9. Okay, that's what comes from these digits. But let me bring down the factors that I get from these zeros. So I'll have a factor of x minus 7 from that, and from the 2 up there I'm going to have a factor of x minus 2. Now I don't think they actually asked us to factor this time, but it's just a good habit to get into, so you always are thinking about how everything works together. So if they had asked us to factor, then this would be it, because x squared plus 9 doesn't factor anymore. So this would now be factored completely. But anyway, so we had the 2 zeros off the chart, the 2 and the 7. But as we said, we're expecting 4 zeros. So we're going to get the other 2 zeros from the x squared plus 9. And it's not factorable, so we'll get it by setting x squared plus 9 equal to 0 and solving. So if we subtract 9 from both sides, that gives us x squared equals negative 9. If we take the square root of both sides, okay, don't forget your plus or minus when you take the square root of both sides. That's going to give us x equals plus or minus 3i. Right? We know the square root of 9 is 3, and if you have a negative under the radical, that's I, so plus or minus 3i. And those are the other 2 zeros that we were looking for. So we have, so if we're going to list all the zeros, right off the chart, we had 2 and we had 7. But then now we also have 3i and negative 3i. So those are the 4 zeros we were looking for. Okay, so that's it for problem number 6. Alright, now let's move on to problem number 7. Students were asked to find all roots of this function. Patricia claims that the only 2 roots are negative 1 and 2. Is she correct? Explain why or why not. Well, alright, the main thing is the degree. The degree of 4 tells us that there should be 4 zeros if we count repeated zeros separately. So the only way that Patricia could be right is if, you know, for example, if negative 1 was a double root and if 2 was a double root. Okay, so for example, if this was a double and this was a double, all right, then that would make the 4 zeros that we're looking for. But remember, if we were to look at the graph, if these are both doubles, then we would expect to find a bounce at negative 1 and a bounce at 2. All right, should be a bounce and another bounce. Another way we could get 4 zeros out of just negative 1 and 2 is if, for example, if negative 1 was a single, but if 2 was a triple. All right, and if 2 was a triple, then that would be an inflection. Okay, where it sort of flattens out and keeps going like that. So, to be sure, we need to look at the graph and see, are there any bounces? Are there any inflections? If the graph just goes straight through, you know, if we have, let's say this is 0 and we have negative 1 and 2, if the graph just goes straight through this thing, like, you know, does something like this and just goes straight through, that means these are singles. So that means there must be additional roots that are imaginary. So let's take a look at the graph and see. Alright, I'm going to use the graphing calculator for this job instead of the TI-30 that I love, because I need to look at the graph. So, looking back at our function here, x to the 4th power minus x to the 3rd power, let's hit y equals and just type this thing in. So, let's see, it's going to be x to the 4th power minus x to the 3rd power. What else? 7x squared minus 9x. Alright, plus 7x squared minus 9x. What was it? Minus 18. So minus 18. So let's look at the graph. I'm just going to hit that graph button, see what I've got. Okay, so it looks like we only have 2 zeros that are visible. But is there any bouncing going on? Are there any inflections? No. It just goes straight through and straight through. Alright, I'm going to adjust the window a little bit, see if I can get a better view on this, really just for fun. I want to see lower to see what's going on down there, so I'm going to change the Y minimum value to something smaller. So let's try negative 20 and see how that does. Alright, so I can see lower now. Okay, not a whole lot going on. I'm going to try it one more time. Oh, whoops, wrong button. Let's try negative 40. Okay, there I can see the bottom of it. So, nothing going on. Alright, it just goes down and up and just straight through. That's what's happening. So there's no bouncing or inflections or anything like that. So that means there must be 2 additional zeros, which are just imaginary. So is she correct? No. So let me just type up the whole explanation off. So here is a really thorough explanation. Since the degree is 4, there should be 4 zeros, counting repeated zeros separately. The only way that negative 1 and 2 can be the only 2 zeros is if one or both of them are repeated. However, I looked at the graph of f of x on my calculator and saw no bounce or inflection at negative 1 or 2. So they are just single zeros. Therefore, there must be 2 additional zeros that are imaginary. So let's finish by answering the actual question. Is she correct? Patricia is wrong. Exclamation mark. Alright, so that's number 7 for us. Okay, write a polynomial function f of least degree that has leading coefficient of 1 and the zeros negative 4, 0, and 3i. Be sure to multiply out the factors. Alright, for starters, you have to remember that imaginary zeros only occur in pairs. They're positive and negative pairs called conjugates. So if 3i is a 0, then that means negative 3i is automatically a 0. So you have to add that in to do the problem. Secondly, we need to translate all of these zeros into factors. Okay, so a 0 of 4 would come from a factor of x minus 4. Okay, a 0 of 0 would come from a factor of x minus 0. Well, x minus 0 is just x. Alright, let me switch colors on this one. A 0 of 3i would come from a factor of x minus 3i. And a 0 of negative 3i would come from a factor of x plus 3i. Okay, so what we need to do is multiply all these things together. Now, if I were you, I would multiply the pink factors together, and I'd multiply the blue factors together, and then multiply all that together. So, to multiply these pink factors together, we are going to, double distribute. So, I'm going to take x and multiply it by everything. So x times x is x squared, and then x times 3i is plus 3ix. I just try to keep it alphabetical when I have more than one variable. You should do the same. And then I'm going to double distribute the negative 3i. So negative 3i times x is negative 3ix, and negative 3i times positive 3i is negative 9i squared. So the next thing that's going to happen is positive 3i and negative 3i cancel each other out. So they're gone. Now there's something we know about I squared, isn't there? We know that I squared equals negative 1. Alright, you should just memorize that. So really this is negative 9 times negative 1. That's what this really is. And a negative times negative is a positive. So this is going to become x squared plus 9. Alright, because it's just negative 9 times negative 1 is positive 9. So that's what we have when we multiply these together. Okay, meanwhile over here, if I multiply these together, all I'm really doing is I'm doing the distributive property. So x times x, that's going to give me x squared. And then x times 4, negative 4 rather, is going to give me negative 4x. Okay, so that's pretty simple. So now I just need to multiply these two things together. So I'm just going to do another double distributive property. So I'm going to take my x squared and distribute that. So x squared times x squared is x to the 4th power. Then x squared times 9 is 9x squared. So now I'm going to take the negative 4x and double distribute that. Okay, so negative 4x times x squared is negative 4x to the 3rd power. Negative 4x times 9 is negative 36x. Okay, now this is the answer except for some of these terms are in the wrong order. So let's just switch it around. Okay, so I'm just going to reverse these two. So then I'm going to have x to the 4th power minus 4x to the 3rd power and plus 9x squared and then minus 36x. I just reversed these two terms because in standard form it really needs to be decreasing exponent order. So 4, 3, 2, 1. And that's the answer. Now we're supposed to call this function f, I believe they mentioned. So there it is. Just if there's an answer line, I'm going to put this on there. Alright, and I can just cut and paste because I got Microsoft Word happening for me in my life. Okay, so there is the answer. Kind of looks cool when I just highlight it like that. But there's the answer to number 8. And that is a good place to stop this video. Okay, now if you were just sort of copying off me as I did the video, you know, that's fine, only as long as now if you take out a sheet of paper and you go back and do the problem by yourself. Copying the problem off of me does not count. Okay, try to do the problem by yourself, either right now or maybe tomorrow. Alright, we'll stop the video here and then I'll pick up the next video with number 9, where we will determine algebraically whether functions are even, odd, or neither. And we'll probably do number 10 as well. Alright, looking at a graph, even, odd, or neither. Okay, that'll be pretty simple. And then we'll get into solving systems of polynomials. That's coming up in the next video. Okay, so stay tuned. I will see you on the next video.